All right. Kia ora. It's just occurred to me that it's Thursday, and I totally forgot to give you guys a recording to kind of process the CPR quiz that I gave you earlier this week. So I'll just make a quick recording to kind of go through it. Unfortunately, I am in isolation, and I don't have a printer at home, so I can't print out these questions to kind of write on, which is mainly what I do when I process, just to kind of show you the how to understand the question. So I'll try to type things up or just write it on a piece of paper. Cool. So let's look at this quiz that I've given you this week. So it's basically just a revision quiz on everything we've covered so far, which is the types of solids, the Lewis structures, and the shapes. With this one here, I've given you 2014. I've gone back a little bit, and the reason why I've gone back is because I wanted to show you this question here. Cool. So Lewis structure-wise, you guys can just click on the answers and see that. The main thing I wanted to kind of talk you through is this diagram here. If you do want me to go through and actually explain any of these Lewis structures, send me a message and I can make a video on it. Anyway, with this question here, it's quite nasty in a sense that they've given you this big molecule and they ask you to figure out information on that big molecule. This is actually quite common. Actually, I wouldn't say it's quite common. It's common for mock assessments. Sorry, that's just my mother-in-law. It's common for mock assessments because they are a little bit harder to kind of process through. So I want to show it to you guys. They don't often put it on the actual NCA exams, but just in case they do, it's good to see it because this one is actually from an NCA exam. Anyway, what you need to do is be mindful of what they have assigned the central atom because that is what you're looking at in reference point. Throughout this whole molecule and throughout larger molecules, there's going to be multiple different angles and shapes at different locations of that molecule because each atom involved is going to have, different amount of things and bonded to it and also different number of valence shells. Or sorry, not valence shells, lone pairs of electrons. So you have to be specific to the area that they're talking about. In most cases, they're really nice and they give you very simple molecules and the central atom is really obvious. But in this case, there is no real center atom because it is a larger molecule. So we are using the reference point of what they're referring to. So they talk about boron in the first example. And in fact, they were really nice and they told you the shape. So that can give you a hint of what the bond angle is if you know your shapes. In this case, we have 3 regions of electron density. So that 3 regions of electron density means it's going to have a bond angle of 120. If you know your triagonal planar shape, you would also know that that's a bond angle of 120. For your second one, you have oxygen. They told you it was bent. Now remember, if I'm accessing the information about bent has 2 choices in bond angle. It's 109.5 or it's 120. If you're not sure, take a guess. These things are great for taking guesses because you have basically a 50-50 chance of getting it right. And that could mean an easy to achieve point. In this case, I see there's 4 regions of electron densities, so that's going to be 109.5 as the bond region. If you wrote 109, they would still accept it. Cool. So with these bond angle questions, they want you to elaborate on why in the same molecule you have different bonds. And they also want you to reference the shape as well and the electron arrangement. With this question, it's really important that you layer it very clearly about what you are talking about. I see a lot of students smash together the justification for bond angle and shape as it's one giant thing. And the problem is when you look at the marking schedule, hopefully my links are working because page is being blocked. That's nice. Hopefully the NZQA website's working because it wasn't working the other day. Now you can see how I find these things. Assessment schedules, structure and bonding, 2014. Let's pull up the assessment schedule. All right, cool. So it's the first one here. What I wanted to kind of point out to you guys is that you need to layer it really well. I see a lot of people smash together the justification for bond angle and shape as one justification. In this case, they don't seem as fussed by it. because the main focus was on the bond angle and not on the shape as a justification. But I'll show you a different exam because that's not a good example. Maybe this one. Actually, no, 2021. They were very, very generous. Let's look at this one here. Here we go. This one's a better example. No, it's not. Maybe 2019. I just want to show you what I mean by like how you layer your answers well and how they can be kind of picky. Here we go. So when you see in this marking schedule here for 2019, you can see how they have an or option. The top bit is that you've explained the shape well, or you have explained the bond angle. The excellence is explaining both the shape and the bond angle. So that's what I wanted to point out to you guys as the difference. So a lot of you guys smash together your answers and then you don't have that clear distinction between what is shape and what is related to bond angle. So with bond angle, be mindful that you should be talking about how many total regions of electron density, because that's the maximum separation, minimum repulsion, aka you should have Vesper theory somewhere in your answer. And then you finish it by explaining how many are bonded and unbonded, and then how that is your final overall shape. They love to use this as compare and contrast, so things could have the same bond angle but different shapes. And this question from 2019 is a good example of this. All of these have the same bond angle, but all of them have different shapes, and that's all related to how many bonded and unbonded pairs there are. So do kind of keep that in mind, and I'll make a note of it whenever I see it in your answers if you're smashing things together and you're not clearly distinguishing the justification for bond angle and the justification for shape. So do keep that in mind. Anyway, we'll go back to the CPR quiz. Cool. And then the last question here was just the types of solid revision. I haven't given you the whole thing because we haven't done solubility yet. But you see here they've done magnesium and they've done iodine. The problem that you have here is that I haven't given you the second half of the question, so you can't really get that hint on the iodine. But you should have hopefully picked it up as a covalent molecular. It is a molecule. And then they love to ask questions on graphene or graphylene, and that's because it does have the electrical conductivity point to it. So that's something they love to ask because it is quite unusual that it does have that. All right, cool. I hope that helps. So yeah, that is, like I said, just a revision on everything that we have covered so far.